Hi, welcome back to the power of model drawing. Now today we are going to look at how do we draw before and after model. So it's going to be quite easy. So once again we are going to focus on drawing out the sentences. Now every time when there's a before and after problem, you need to ask a very important question. What is unchanged or everything changes? Now when something is unchanged, there are three answers that you have to think of. Is it one group unchanged, or is it total unchanged, or is the difference unchanged? So usually when something is unchanged, the model is easier to draw. Okay, so let's look at example 1. Jimmy is 20 years older than Katie, and the ratio of their age is 5:1. How many years later will the ratio of Jimmy's age to Katie's age becomes 3:1? Okay, so you can see that this is clearly a before and after problem. So what is the before? What is the before? Now the before is the ratio, which is 5:1. That is the before ratio. And then what's the after? The after is the after ratio, which is 3:1. And whenever there's a age-related problem, but it's unchanged, the age difference is always unchanged. So you may have to remember that. Okay, when there's a age problem, the age difference is unchanged. Okay, so how do we draw the model? Now, let's draw the before model. So Jimmy is 20 years older than Katie, and that is the age difference. So no matter how many years later, what happens? Jimmy will always be 20 years older, right? Okay, so it's 5:1. So draw let's draw Jimmy's rectangle and cut it into 5 boxes. 1, 2, 3, 4, and 5. So you have 5:1. Alright, so as much as you can, try to make the model as proportional, right? But just remember that your model is never perfect. As long as you label properly, alright, you should be able to use the model to solve. So this is the ratio, which is the before ratio, and the age difference is 20 years older. Okay, now how many years later will Jimmy's age to Katie's age become 3:1? So of course, common sense, right, tells us that their rectangle will become longer. So Jimmy's rectangle will become longer, and there will be 3 boxes to cut, right? 3:1. Katie will have 1 box, right? 3:1. Okay, and how many years later? So can we put the question mark in the model? Now, if you're not so sure about where to put the question mark, then you don't put the question mark. All right, so we have completed the model. So that's how the model looks like. And of course, the age difference is always the same. All right, now if you look at the model, you can see that the difference, right? Jimmy has 4 boxes more than Katie in the before. And in the after, Jimmy has 2 boxes more than Katie. So can I make the number of boxes the same? Yes, I can. What I will do is, I will look at the after model, and can I cut the 2 more boxes that Jimmy has into 4 more boxes? All right, like this. Okay, so you can see that now you have 4 more boxes already, right? So you have 1, 2, 3, and 4. So you can see that Jimmy is 4 units older than Katie. And if you look at the before, it's also 4 units older than Katie, right? So you have to make the difference the same. What is unchanged? Make the number equal or make the number the same. And once you cut it, what do? All the boxes, they all look similar. So every box will be called 1 unit. And now you can see how many units is equal to 20. So that will be 4 units is equal to 20. And 1 unit will be 20 divided by 4, which is 5. Alright, so can you find how old is Katie now? Right, which is 1 unit. That will be 5 years. Then how old will Katie be in the future? That will be 2 units. So 2 units means 10. So Katie will be 10 years old some years later. And can you see how many years later will Katie be 10 years old? So you just take 10 and you minus 5. So you can see that in 5 years time, Katie will be 10 years old, right? How about Jimmy? If you look at Jimmy, how old is Jimmy at first, which is 5 units. So 5 units will be 1 unit is 5, so 5 times 5, 25. Then how old is Jimmy some years later, which is 6 unit, right? 6 unit. Alright, so 6 unit will be 6 times 5, which is 30. So Jimmy will be 10 years old some years later. And if you look at the how many years later, that will be Jimmy, which is 30 years in the future, and then you minus how old Jimmy is now, which is 25. That will give you also 5 years later. So which means that in 5 years time, what happens? In 5 years time, the ratio of Jimmy to Katie, age, will become 3:1. Okay? So what's the lesson here? The lesson here is the age difference is unchanged. So whenever there's an age-related problem, then the age difference is unchanged. So what do you do with the model? You look at the difference, and then you try to make the difference to be equal, right? To be equal by cutting the boxes into smaller parts. Okay, now let's go to example 2, and let's see how do we do the next one. And you need to think about what is unchanged or everything changes. Now, Patrick received an equal number of local emails and overseas email in June. When he deleted 20 local emails and 195 overseas email, the ratio of the local emails to the overseas emails became 12:5. So how many overseas emails did he have in the end? So what is unchanged? Now, in this problem, everything has changed because he deleted 20 local emails, so there'll be lesser local, and there will also be lesser overseas emails. And how about the difference? Is the difference unchanged? Then you need to ask, did he delete equal number of local emails and overseas emails? No, he didn't. So the difference is also changed. So everything changed. Then how do we draw the model? Okay, now this is how you draw. So your before model will look like this. Okay, before. All right, let me just label nicely. So Patrick received an equal number of local and overseas. So I would draw 2 equal rectangles, right? Equal, right? And I can actually put the before and after together as one. If you notice in the previous lessons, sometimes we don't have to separate the models. We can actually merge them together. So it depends, all right? It's up to you whether you want to put them together or to separate them. So over here, I would like to join them together because it's easier. Alright, so the after model, how does it look like? Now, he deleted 20 local emails. So you cut here, 20, that's taken away. And then he deleted 195 overseas emails. So what will happen to the after model? Now the local email will have a shorter box, and the overseas email will also have a shorter box, which is the blue rectangles. So the blue rectangles is the after, right? The after model. All right, and then what does the ratio? What is the ratio for the after? Now, in the end, the local to the overseas became 12 units and 5 units. So when you have ratio, you will call them units, okay? Because ratio, they are in units. So 12:5 means 12 units and 5 units. All right, 12:5. So how many local or how many overseas emails did he have in the end? So your question mark is over here. Okay, so that's your model, a very simple model that you can draw. And now we look at the model and what do we do? Now, one of the guidelines to model drawing is to think about the difference. After drawing the model and you don't quite know how to do, you think about whether can you find any difference. For example, you look at the units. What's the difference in the units? That will be 7 units. Alright, the difference is 7 units. And then you look at the whole numbers. What's the difference? 195 minus 20, the difference is 175, which means that your 7 units is the same as 175. So your 1 unit will be 175 and divided by 7, and you will get 25. Alright, so can you find how many overseas emails did he have in the end? Which is 5 units, so 25 times 5, and 125. So that's how you use the model to solve the problem, and it's a before and after. So in this problem, everything has changed, but we can still apply the model drawing. We can still apply the method over here. Okay, now let's move on to the next one. All right, so hopefully by now you have an understanding, you have a good feel of how to draw the model for before and after. All right, so let's look at a few more. Now let's look at practice problem, and I will give you about 5 to 10 minutes and try and draw the model, and then you can when you have gotten the answer and you have drawn out the model, then you can play the video again and see whether your answer is correct. Alright, so your time starts now. Okay, so have you managed to draw the model? Alright, let's see how to withdraw. Now the ratio of Joe's money to Kim's money is 3:7. After Joe passed $50 to Kim, the ratio of Joe's money to Kim's money became 1:4. Now there's a transfer. Joe transferred $50 to Kim. So when there's a transfer, the total is unchanged. So how much did Joe have in the beginning? Alright, so total is unchanged. So let's draw out the first sentence. By now you should know that model drawing has we don't solve when we draw the model. When we draw the model, we just focus on the drawing. So we draw sentence by sentence, and then after that you think about how to solve by looking at the model. So Joe to Kim is 3:7. So let's cut 3 boxes, and Kim will have 7 boxes. 1, 2, 3, 4, 5, 6, 7. Okay, so you draw until here. Now after Joe passed 50 to Kim, what happens? Now Joe to Kim's money became 1:4. Okay, so let's draw the after model. So in this problem, it's better to separate the model so that it's easier to see. So when Joe passed money to Kim, so of course Joe will have a shorter rectangle, right? And then Kim will have more, right? Kim will have more money because Kim gets money from Joe. So Kim will have a longer rectangle than before, and not only that, the ratio is 1:4. It means that Joe has 1 box, 1 unit, and Kim will have 4 boxes, right? 1:4. Okay, that's how you draw the model. All right, so when you draw the model, try to show the difference clearly. For example, when Joe has given the money to Kim, then Joe's rectangle will have to become shorter in the end. And when Kim received money, then Kim's rectangle will become longer in the end. So you have to show the shorter and the longer, right? Okay, now, then can we put the $50 into the model? Yes, you can actually, but if you find that it's a bit messy to put the $50 in the model, then you can ignore, right? You can leave it out, and I think Mr. will leave out the $50 so that the model looks as clean as possible, right? As neat as possible. Okay, now, so how much did Joe have in the beginning? So the question mark will be over here. And we are done with the model. So what is unchanged? The total is unchanged, but we don't know what is the total money that they have. But don't worry, if you don't have the total money they have, you can always count the total units. So in the before model, how many units they have altogether? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in the before model, there are 10 units altogether. And in the after model, there are 5 units altogether in the after model. And if the total is unchanged, what do you do? You have to cut it or make it the same. So you take 5 units times 2. Okay, by the way, I should not call 10 units and 5 units because the boxes are different. So I should call 10 and 5. Okay, so they represent different boxes, so you can't call them units. So 10 units and 5 parts, or 10 and 5. Alright, up to you on how you want to label them. So if the before have 10 boxes and the after has 5 boxes and the total is unchanged, then I have to make the number equal because the total is equal. And I get 10. So once the numbers are the same, I call them the same thing. I call them all units. Alright, now we can start cutting. So 2, 4, 6, 8, and 10. And every box is called 1 unit. Okay? And now we can start to solve. So you can see that Joe has given how many units to Kim. So from 3 units, Joe has 3 units, and he must have given 1 unit, right? Because now he has 2 units left. And if you look at Kim, Kim has 7 units at first, and he gets 1 unit from Joe. Now Kim has 8 units in the end. So which means that the 1 unit that Joe has given away is $50. So 1 unit is 50. So how much did Joe have in the beginning, which is 3 units? So you have 50 times 3. which is $150. So that's how you draw the before and after model. So it's a very simple model. Once you can draw out the model, you can see the steps are actually not many steps, and actually the solving gets faster as well if you can draw out the model. Alright, so we come to the end of this lesson on before and after. So we'll be looking at some more lessons on model drawing. So stay tuned to the coming up and coming lessons. But more importantly is you should always try to practice your model drawing whenever you see questions that allow you to draw model. So put your focus on the model drawing. All right, when you do your homework or when you do your questions in the exam papers, always try to practice on the drawing, because the more you practice, the better you get, and then the easier to solve the next time. All right, so I'll see you in the next lesson.